Hello, welcome to another video by LSX Engines, Tuning, and Marine. In this video I'm going to show you how to index a crankshaft position sensor on a non-LS engine. In other words, the purpose of this video is to show you how to retrofit or transfer General Motors fuel injection electronics, namely the coil near plug and sequential fuel injection, over to an engine that might not necessarily be a GM engine. In other words, if you mount a crank trigger wheel and a crankshaft position sensor and the cam position sensors, you can put the General Motors electronics, the fuel injection system, on any other engine. It could be a Jeep, it could be a Ford, it could be any older engine that's not carbureted, or excuse me, not fuel injected. You can put fuel injection on any engine that you can mount a crankshaft trigger wheel to. However, you need to make sure that when you put the General Motors crankshaft position sensor and the trigger wheel on there, that they are indexed properly to top dead center on the number one cylinder. So having said that, what I've got here, I've got a steel plate right here bolted down to the top of the block with a bolt or a stop in there, or a 3/4 inch fitting going down there, and that's what stops the piston from coming up. So that's my piston stop. And it's bolted on there very rigid. I've got it bolted down through a socket, 1/2 inch drive socket, through an old cylinder head bolt, and this is not budging. It's in there good and tight. So as I turn the piston, it'll come up and hit that stop in one direction, and then I'll rotate it the other direction and hit stop going the other direction. And at each stop, when it stops at each direction, I'll make a mark on the trigger wheel to show how where those stops occurred, and then halfway between those two marks will be top dead center. So you'll see what I mean when I show you when I video what I'm doing. But for now, just know that this is my piston stop, and I'm now about to flip the engine over so I can rotate it and mark the trigger wheel. All right, I've now turned the engine as far counterclockwise as I can against the piston stop that I installed, and I made a mark on the bearing cap and the rear main seal journal. So those two marks line up on that side, at that stop. Now I'm going to rotate the engine clockwise as far as I can, and then I'll get marks over here on this side, and then halfway between the resulting marks will be top dead center. Okay, I've now rotated the engine clockwise as far as we'll go against the piston stop, and I've made another mark over here. So, or actually I made a mark here. So the mark with the dot is my primary pointer that I'm looking at. I just made that mark on the journal just to have a line to measure with. So I'm now about to measure between these two marks, between the mark by the dot and that mark on the journal, measure the distance, and half that, make a mark on the half that distance, and then make a mark on the bearing cap, and then move this dot mark back to there, my primary mark, and that'll be top dead center. Of course, I have to move the stop to do that. But let me go ahead and measure that distance and mark the halfway point, and then I'll show you that before I move the piston stop. All right, I've now measured the distance from this mark here over to this mark here, and it turned out to be 1.5 plus 5/16 to there in both directions. So I'm using a tape measure laid flat. I measured 1.5 inches plus another 5/16 to there, whatever that is. Well, 1 and 8 and 13/16, 1 and 13/16. So it's 1 and 13/16 from there to there, and from there to there. So then I transferred that mark up to here, and now that's my top dead center mark. That mark right there is top dead center when I move my primary mark here with a dot back up to right there. So I'm about to do that. I've got to remove the piston stop and then rotate the crank till this dash here lines up with that on the bearing cap, and then I'll be at top dead center. And then to prove that, I'll rotate the motor over and show you that number one is at top dead center. All right, I've now rotated the engine to where the primary mark is lined up with what I'm calling top dead center, that line right there on the bearing cap. So now that that's lined up, we should be at top dead center on the number one cylinder. So instead of flipping the engine over, I'm just going to show you by looking at the bottom of the engine, or looking at the number one cylinder. And there you can see number one cylinder is at top dead center. So now that we know that this engine is at top dead center, our end goal was to find out where the crank position sensor was pointed at the trigger wheel when it's at top dead center on number one. So now we're at top dead center on number one. Let's see what we got. So if you look down through there, your crankshaft position sensor comes in this hole right here. and looking down through there, that's an old mark. Just ignore that black mark on there. I made a mistake earlier before I made this video, but I don't see anything that stands out that would have made me guess where this thing was. That this is a non-intuitive answer or non-intuitive solution to this issue. So what I did, I've already done it off camera, is if you look down through there, see, let me show you. So right inside there, I made a black mark right above that tooth. So you see what I'm talking about. So if you look right through there, maybe you can't see the black mark, but right above the tooth that looks like it's in the just below the middle of this hole, I made a black mark. That's your center of your crankshaft position sensor. So now that I have that marked, I can come back up here, rotate this wheel back up here, and see what the characteristics are. There's nothing that's intuitive about that location. So GM must, it may be triggered off of number 2 or number 3 top dead center. I don't know. When I say what I mean by trigger, I mean indexed. But there's nothing that on the trigger wheel that stands out about that location. So I'm going to move the crank back up to where that mark comes around and see what happens. So this trigger wheel is called a 58 tooth trigger wheel, and it has a uniform number of evenly spaced notches in this wheel except for one spot, and there's a gap right there. So what I'm going to do is take that gap and run it down to the crankshaft position sensor hole and just see where the engine ends up. See what's unique about, or what stands out about that location. It may be that it's indexed off of cylinder number 6 or 4 or 8. I don't know. So I'm going to find out. I'm going to move that to the hole and then see which cylinders are near top dead center. All right. Off camera, I've discovered something interesting. So what I've done is I rotated this trigger wheel until that gap in the 58 teeth lines up with this hole in the, if you can see it there, this hole, the crankshaft position sensor hole. So what you're looking at is the first tooth. The gap starts after that last tooth you're looking at. So it just so happens that when this trigger wheel is rotated to where that last gap lines up with this hole, cylinder number 2 is at top dead center. So what I'm going to do, I'm going to repeat this entire experiment or entire process, but instead of using the piston stop on cylinder number 1, I'm going to use cylinder number 2 and get an accurate location for the top dead center cylinder number 2, and then see where this trigger wheel points. I'm going to do all that off camera. I've showed you the process. I just used the wrong cylinder. So now that I know which cylinder to use, I'm going to lock down cylinder number 2, find top dead center number 2, and then see where this crankshaft position sensor points at this trigger wheel. I'll do all that off camera, and then I'll report the results when I'm done. All right, I've now redone the entire procedure, but I used cylinder number 2, the piston stop on cylinder number 2, and found top dead center of that cylinder, and I marked it here. Again, that's top dead center of cylinder number 2. And since I used the same depth piston stop, it was still 1 13/16 over from the other marks. But anyway, so when I marked the trigger wheel inside the crank position sensor hole right here, you can see the mark I made. So that black mark is right in the middle of the hole. All right, so here's the final result. So you can see the mark I've made in this wheel about right there, and I don't think it's a coincidence that it lines up with this hole where they were removing weight from the crank. So I made that mark right there, where my fingernails at, and that's in the middle of the crank position sensor hole when this crankshaft is in top dead center on cylinder number 2. Again, this is not the outcome I expected. I would expect them to be maybe the last notch or the first gap or the first low spot on the wheel after the last trigger going that direction, but it's not. It's over here somewhere, or it's over here in the kind of a 35% of the gap, the way through the gap. So that is not the answer I expected on this solution. But so let me summarize. So if you put a 58 tooth trigger wheel, and by the way, I will extrapolate this information onto a 24 tooth trigger wheel, so you can do the same thing, because there are index marks that are similar between the 58 tooth and the 24 tooth trigger wheel. But on the 58 tooth trigger wheel, this mark right here and I'll give you an exact measurement with a dial caliper in the description from this tooth. So the crankshaft is running clockwise, so it's turning that direction. So as the teeth go by, this will be the last tooth before the gap. So after the last tooth, you got this much space to when the crank position sensor will recognize there's not a tooth there. Maybe that's what it is. Maybe this distance could be that mark is the first spot where a tooth should be, but it's not. That's what it looks like, maybe. I'm going to take a caliper. The distance from this center of this tooth to the center of that tooth, and from the center of that tooth to that mark is the same, then that must be it. So when it's missing that tooth, it knows that's top dead center on number 2 cylinder. All right, it's now been about 24 hours since the last recording segment of this video, and I had stopped the camera because I had several realizations all of a sudden that I needed to think through. But before I get into that, I want to say this. So my videos are unscripted. I don't have a script that I'm going by, as you'll see as I'm talking now. And because of that, sometimes I get maybe a little bit tired, or maybe a little bit winded, or a little bit rambling, or whatever you want to call it. And at the start of this video, I was kind of doing that. And I want to make something real clear right now. So the purpose of this video is not for LS engine owners. If you already have an LS engine, this doesn't apply to you. This video is for hobbyists who want to retrofit LS engine management systems to some other engine, like maybe an AMC V8 or an old carbureted engine from the 1960s or 70s that doesn't have fuel injection. If you install a LS crank trigger and its crank position sensor and the cam sensor and its trigger in the distributor, you can get the OBDII engine management system, LS OBDII engine management system to run any other car. And people who are doing that need to know this information. So that's what this video is about. So I just want to straighten that out. And apologize for the start of this video where I wasn't real clear about that, I don't think, anyway. All right, so as I was saying, another thing, if my videos are unscripted, sometimes you'll hear me start to talk slower, or pause and seem like I'm rambling or lost. Well, the reason I'm doing that is because as I'm speaking, I'm also thinking, and sometimes I'll have realizations or something pop in my head, and I realize that either what I'm saying is wrong, or I'm missing a point, or I need to add more to it. So that's why I stopped the video when I did and started back up now. So so far up to this point, I'm a little bit embarrassed by this video, because everything I've done up to now was I was experimenting and trying to find some things, and in hindsight, knowing what I know now, I should have gone right to the solution. It's obvious to me now, but at the time it wasn't. With my knowledge of things, I should have figured it out much sooner than I did. And I thought about erasing this video or deleting it and starting over, but I thought, no, I'll just leave it, and the viewer might get a kick out of seeing how I arrived at the solution, even though it took me a while to get there. So as I was saying, the realizations I had were, one, these things hit me all of a sudden in my head, and it just almost stopped me in my tracks of what I was doing with this video. And the first realization was that this is not a small block, and the firing order is different from a Chevrolet small block. And I really want to focus on that fact, but I guess in the back of my head, I was thinking cylinder number 2, this engine was keying off cylinder 2, because the number 2 is the last cylinder in the firing order before 1 starts over. So cylinder 2 fired in a Chevy small block. Cylinder 2 fires, and then 1 is right after it. So 2 is right after 1. But like I said, in the process of doing this video, well, let me back up. So when I had the crank position sensor, or when I had the crank rotated, where that gap is right there, the gap down there, I don't know if you can see it, there's a gap in the tree. And in this hole right here, that gap is lined up with a hole. It just so happens that cylinder number 2 was the first cylinder I saw. There's number 2 right there. And it's at top dead center. And that's the first cylinder I saw, so I kind of keyed on that. Well, I'm not saying it was a mistake, but that kind of threw me off. So like I said, the 2 realizations I had was, 1, this is not a Chevy small block, and 2, If you remember some of my previous videos when I talk about marine ignition timing, PCMs can't predict the future. They can only cause events after a trigger, not before a trigger. You can't take an action before you know about the action. So the trigger on these kind of systems, on the trigger wheel systems, the trigger happens 30, 60, 90, 120 degrees before the event they want to take place. So that's a key concept that you have to understand. So when those two realizations hit me, I suddenly realized I need to check the firing order of a LS engine. So that's what I did. I stopped the video and went and dragged up the firing order, and here it is. So this is the firing order of an LS engine. This is important. So like I said, I keyed on 2 just because it's the first cylinder I saw when I had the trigger wheel with the gap in the hole where the crank position sensor would be. There's 2. But if you notice, 2 and 3 are opposing cylinders in the firing order. What that means is when 2 is at top dead center, so is 3. So there we go. So we're going to look over here on 3, and there's 3 right down there. So 3 is also at top dead center. I didn't key on that last time. But when you look at the firing order, that's what suddenly dawned on me. Okay, now I understand what's going on. I understand the solution. So remember, you're trying to find an indexing point for cylinder number 1. Well, guess what it is? It's number 3. 3 fires right before 1. So 2 is not the cylinder to key on. 3 is. 3 being top dead center means that when the gap in this wheel is lined up over here on the crank position sensor, it's number 3 that's at top dead center. 3 is 90 degrees before cylinder 1. So what they're doing, and it's common in calibrations and General Motors calibrations, that the event they want to trigger is 60 degrees or 60 degrees before. Like in the old V6s, it was 60 degrees before the event. So they have the trigger be 60 degrees before top dead center on, say, cylinder number 1. In the case of an LS motor, it's 90 degrees because each cylinder in this engine, it's a V8, so there's 4 firings per revolution, so each firing is 90 degrees from another. So number 3 cylinder fires 90 degrees before number 1. All right? So that means number 3 is at top dead center when this crank position sensor is pointing at that gap. Like I said before earlier in this video, the first tooth that's missing in the gap. And by the way, it's called a 58 tooth trigger wheel. It's actually what's called a 60 minus 2. It's really a 60 tooth trigger wheel minus 2 teeth. And what that means is there's 60 teeth between there's 60 teeth in 360 degrees, which means you get 6 degrees of resolution between each of these teeth on here. The gap just means you got 2 teeth to have a trigger point, but the teeth, the PCM still counts up to 60 teeth, if you understand what I'm saying. So the bottom line, to summarize, is that when you set up a system, an LS system, you want to set it up so that it doesn't matter what the firing order is. So the only thing that matters is you take the very last cylinder before number 1. Usually, if it's a V8, it's going to be this cylinder here. So you take the last cylinder, that's the cylinder you want at top dead center when this crank position sensor is aimed at the first missing tooth in the trigger wheel. I don't know if it's clear, but like I said, this could be any cylinder. It doesn't matter. If the firing order of an international harvester is the last cylinder is number 5, that's the one you set at top dead center because 90 degrees from 5, if 5 is here, 90 degrees from 5 will be number 1. And so if you have your crankshaft position sensor aimed at the gap, the first missing tooth in the gap, that's when you want to have that number 5 at top dead center. It's now pretty crystal clear to me how this works. Of course, you also got to get your cam sensor set up and all that stuff. So I apologize for the length of this video, and I'll put in the description how to get to the point. This part of the segment, or this segment of the video, where you can go right to it and understand what I'm saying. And again, the summary is you want to have the last cylinder in the firing order be at top dead center when you line up your crank trigger wheel. I think that wraps it up. I'm going to stop the video now, and if you have any questions, please leave them in the comments. And again, sorry for the length of the video. I just felt like it might be interesting so that my viewers can see how I kind of rambled on and had to think this through. And then I had a couple of sudden realizations, and all of a sudden it dawned on me what's happening. So that's it. Again, if you like the video, please subscribe to my channel. And if you have any questions, put them in the comments. Thanks for watching.